Okay, welcome back to part 3 of section 5.5. We're still doing integration by substitution. So we're taking a look at more examples here. Just more and more examples of what we could run across that would make this happen. All right, so here I've got our latest example. We're supposed to do the integral of sine x divided by cosine cubed of x dx. Now, last time I saw division, I rewrote it and it kind of worked, so I'm going to try that again. I'm going to write this as the sine of x times the cosine of x raised to the negative 3 and then dx. And so now I'm looking at this and I'm saying, okay, there's my composite part. This is the inside of the composition, so that'll be my u if this works. So let's try that. We'll say that u is cosine x, then our differential du would be negative sine x dx. I got a problem. This is missing the negative, so I need to algebraically fix that. So negative du is positive sine x dx. I think that's working. So now I'll do the substitutions. Right? I'll replace the u for the cosine. I'll replace the negative du for that dx that's sitting there and that sine x that's sitting over there. And then that's going to give me the integral of u to the negative 3 times negative 1 du. And I'm just putting that 1 in there to kind of clarify that this isn't subtracting du, it's a negative 1 times it. Okay. All right, so both things that are supposed to happen happened when I did my integration. That is, I got something that's much less complicated down here, and also all the x's turned into u's. Now I'll perform the integration. The negative 1 is a coefficient, so it just drags along. The integral of u to the negative 3 is going to be u to the negative 2 and a negative 1/2 in front. And of course plus c because we are doing indefinite integrals. Right? Two things are still wrong with this. I need to clean up this algebra and I need to get rid of u, do a back substitution for cosine x. Okay? I'll perform that. I get 1/2 times the cosine of x raised to the negative 2 plus c. Now, this is one situation where you might have an issue with writing this as your final answer, because I do remember some of the homework problems said that your final answer can't have a negative exponent in it. And so then we'd have to rewrite this as 1 over 2 cosine squared x, of course, plus c. Right, so just be careful. Make sure you take a look at those directions, because sometimes it will say that in the directions that the final answer can't have negative exponents. I don't know why. I don't know why it does that sometimes. I just know that it does. So it's just something to be aware of, and then if you're aware of it, it shouldn't be a problem. Yeah. Okay. More examples. Ooh, hey, I remember doing one like this before, so I know what to do. I'm going to rewrite first of all so it's easier to see. This is the integral of the cosine of 2x cubed multiplied by the sine of 2x dx. There's my composite because that's cubed. So then we'll let u be the inside piece. The differential then du is going to be I missed a negative there. That's what I'm trying to erase to fix. The differential du is going to be negative sine 2x times 2 dx. This matches here mostly. I'm missing a negative 2, so I'll do the algebra that I've been doing. That's going to give me a negative 1/2 du is sine 2x dx. And now I'll perform my substitutions. So I get the integral of u cubed times negative 1/2 differential du. Okay? This became the u, and this became the negative 1/2 du. Both things that are supposed to happen in substitution happened. That is, I now have an integral that's easy to do, u cubed, and all of the u's went, or all the x's went away and gave us u's. There's the negative 1/2 that's a coefficient. Antiderivative of u to the third is going to be u to the add 1 to the x. Okay, so 1/4 u to the fourth, and of course plus c. I'll deal with this and with that. Negative 1/8 cosine 2x to the fourth power plus c. And again, like I said before, if you are at all concerned that maybe you've done this wrong and that maybe this isn't the right final answer for you, take the derivative of that blue line there, see what you get. You should get the original cosine cubed sine 2x business. Okay? All right. This one's going to be hard. I'm just warning you, because this one is a challenge that we haven't faced yet. Okay? All right, so once again, I've got an integral. I've got a composite part. I got two things being multiplied together. I'm thinking substitution, so I'll try substitution. U is 2x minus 1. Then the differential du is 2 dx. Right? I just have plain old dx, so I'm going to call that 1/2 du is equal to dx, and I'll perform my substitutions. I've got u to the 1/2 times 1/2 du, but I've got a problem. This never went away, so it's still sitting there, x times. Under the root, substitute it out for u. The dx substituted out for 1/2 du, but this x never went away. And if it never got substituted out, then it's still there. So the two things that are supposed to happen to make substitution the right way to do a problem didn't happen. One of them didn't happen. All of the x's didn't go away. So that means that one of two things is true at this point. Either I have incorrectly performed my substitution, or maybe substitution isn't the right way to solve this problem. Maybe I need something more. Right? Oh, but wait a second. There's a third possibility. And I know that you hate whenever an instructor says, wait a second, but there's a third possibility. Could I find a way to make x substitute out if I did some algebra on that? If I took that line and said, okay, that means that u plus 1 is 2x, and that u plus 1 divided by 2 is equal to plain old x. Can I now do a second substitution? And then this will become the integral of u plus 1 over 2 times u to the 1/2 times 1/2 du. Right? All of this just stayed the same. It was the substitution here that occurred, where I replaced x with u plus 1 over 2. Okay, now I got to figure out what to do with this mess. Right? It looks like it's going to be hard to integrate, but if I do a couple more tricks with the algebra here, I'm going to take this and call that 1/4, and I'm just going to put it out in front of the integral just to get it out of the way. I'm going to call this a binomial and this a monomial and distribute that monomial into that binomial by substitution. And then my integrand is going to become u to the 3/2 plus u to the 1/2 du. And now both things that are supposed to happen happened. All the u's went away and I've got something I can integrate. It just took a little longer to get there. Okay? So now I'll do calculus. I'll do the integration. Right? The 1/4 is a coefficient, so it just drags along. The first term, u to the 3/2, is going to become 2/5 u to the 5/2, add 1 to the exponent. The second term, u to the 1/2, is going to become 2/3 u to the 3/2, add 1 to the exponent. And then, of course, plus c on the end because we're indefinite integration. Two things are still wrong with this. I need to deal with multiplying that coefficient in, and I need to deal with replacing u's with what u stood for. And what did u stand for again? Oh yeah, way up at the top there is 2x minus 1. And so now when I distribute, I'm going to get, let's see, 1/4 times 2/5 is 1/10 of 2x plus 1 to the 5/2 plus 1/6 times 2x plus 1 to the 3/2, and then plus c. And I have done my integration. Why did that 1 disappear right there? I'm going to put that back in. 1. Okay, I've done my integration. This is a tricky problem. We've not seen this one before. Okay? Every other problem we've done, once we figured out what to do, we were able to get all of the x's to substitute out on that first step. This is the first problem where the x's all didn't go away and we had to do a second substitution. It's not a different substitution because it isn't like we said, let's define another variable like v to be something. We just used the same substitution statement that u is equal to 2x minus 1. We just did some algebra on it so we could isolate x and make that substitution happen. This is a challenging substitution, but it is still a substitution problem. Okay? Again, if you're at all concerned that the answer is correct, just take the derivative of that black line right there. Do a whole bunch of algebra to get common denominators and clean things up and all that business, and it will take you back to this problem up here. Okay? All right, let's try it again. This is the same problem, just a tiny bit harder. Okay? All right, you ready? I see two things being multiplied together, a root times an x to the 5th dx. Since those two things are being multiplied together, I'm going to try substitution. Whenever I try substitution, I pick the inside of the composite function to be u. And then the differential du is going to be 2x dx. Or, oops, So how do I make this thing work? Because this doesn't look good at all. Because if I attempt to do my substitution, okay, first off I need to deal with this 2, so I'm going to call this 1/2 du is x dx. If I attempt to do substitutions, I'm going to get this, u to the 1/2. And I think we're all going to be okay with that because that's just this root right here rewritten, right, with our u. And then multiplied by, and here's where things are going to get ugly and people aren't going to like this, 1/2 du times x to the 4th. How on earth did this lovely x to the 5th dx become all of that mess? Okay? So as a little bit of scratch work over here to the side, x to the 5th dx is x to the 4th times x dx. I'm just taking algebra and working it here. X dx, 1/2 du. But the x to the 4th is still there. So I have a problem. I have x's still sitting in my substitution problem that I need to make them go away. Well, the last time I had x's still left in my substitution, I went back to the original u statement and used it to make them go away. So guess what I'm going to try now? But I don't need x squared, I need x squared squared. And now I'll try that substitution there and see, hope, pray that something good comes out of this. So now my integral is going to become the integral of u to the 1/2. That's just copying down. 1/2 du, still just copying down, and u minus 1 squared. And what I'm hoping is that with a little bit of algebra, I can clean up that integrand and make it be something that I can actually integrate. So next step, algebra. I'm going to pull the 1/2 out in front of the integral because I don't want it there. I still have u to the 1/2, and it's going to be multiplied by u squared minus 2u plus 1 du. Now, if you're wondering where that trinomial came from, this trinomial is that binomial just squared. I just actually did the algebra of squaring it, multiplied it out. Now I'm going to distribute into those three terms of that trinomial, and I'm going to have 1/2 times the integral of u to the 5/2, u to the 1/2 times u squared, minus 2u to the 3/2 plus u to the 1/2 du. And now I do have an integral that I can integrate. So now I'll integrate term by term, just working from left to right. That 1/2 out in front is still there. U to the 5/2 is going to become 2/7 u to the 7/2 minus 2 times 2/5 u to the 5/2 plus 2/3. Sorry, got ahead of myself there. U to the 3/2. And of course plus c because this is an indefinite integral. Right? Two problems to deal with. I need to deal with all the algebra, the distribution of this 1/2 here into all of those terms, and I need to back substitute for all those u's. And what was u again? Oh yeah, u is 1 plus x squared. And so first term when I distribute, I'm going to get 1/7 times 1 plus x squared to the 7/2 minus the 1/2 times this, so minus 2/5 times 1 plus x squared to the 5/2 plus 1/2 times 2/3 is 1/3. 1/3 times 1 plus x squared to the 3/2, and of course plus c. There's my hot mess of an answer. And then at this point, I'm going to call that done. All right. This brings us to the end of the indefinite integration part for substitution. The next video will pick up here with definite integrals. So I'll see you all back here for part, what is that, like 4 of this, for definite integrals.